Alright, let's work up to our definition of a derivative by just starting with straight, normal, y equals mx plus b lines. So if I ask you the question, what is the slope of this line, what would you say? Well, traditionally you're introduced to slope as slope equals the rise over the run of a line, like we have right here. So if I want to determine the rise over the run, that would mean I would determine how far we moved in the y direction, how far we went up or how far we went down, and then divide it by how far we went across. So let's pick any 2 points on this line and then figure out how far we went up and then figure out how far we went across. This is also written as the change in y. That's the increment that you increased in the y direction, so that would be up that much, and then over delta x, or your change in x. And that is how far did you go across, which would be our run, which would be like that. So let's pick 2 points on this graph. So now we have 2 points picked out, and let's call this one, so if our graph is f of x, and this point right here, this x value right here is a, then what will the y value be? Well, if we plug in a for x, our y value would be f of a, right? The function value at a is what the y value is at a. And then if we have point here, our x coordinate is b, and our y coordinate would also be f of b. So now we have 2 points, and now we can find the slope. So if you remember from, this is just algebra 1, right? For your algebra 1 days, y2 minus y1 over x2 minus x1. This makes a ton of sense. All you're doing is you're going up a certain amount, this is your rise, and then you're going over a certain amount, and you just divide the y increase increment divided by the x increase increment. So our f of a is, or our f of b is this far off. I'll just draw a big vertical line. That's how far off it is from the x-axis. And then our f of a is this far off of our x-axis. So if we subtract this shorter line from our longer line, we just take this part away from it, and we're left with this, which is exactly what we wanted, our increase in y. Similarly here, a is this far off, b is this far off. If we take this minus this, we're just left with what we increased here, which is our delta x. Anyway, y2, that's our y coordinate for our second point, minus y1, that's our y coordinate for the first point. So I'll rewrite this as f of b minus f of a, and that's just saying how far up did we go, divided by x2 minus x1, b minus a. So this is just what you learn in Algebra 1, slope review, right? You have a straight line, pick any 2 points on the line, figure out the rise, figure out the run, divide the rise divided by the run, and then that gives you your slope. And it's for any points you pick on this line will give you the exact same slope, because this slope here, mx plus b, will always be m, right? We don't know what this line is, but we know that the slope is the same for the whole line. So here's where it gets really interesting. Now if I ask you the same question that we asked up here, what is the slope of this line, what would you do? So our original definition of slope was that we had to have 2 points, and in our lines, our straight lines, if we picked any 2 points, it didn't matter what 2 points we picked, we would always get the same slope. So let's try that out over here and see what happens. So if we pick 2 points, let's pick a point there and a point there. If we look at the rise, that's up to here, and if we look at the run, that's over to there. So connecting those two, the rise and the run, we draw a line between the two, triangle, like we drew a triangle here, but in this case it was a straight line, so the hypotenuse was already drawn. But if we draw a straight line between the 2 points, this is the rise, this is the run, this is where we ended up, this would be the slope of our line for these 2 points. Now what if I pick a pair of different points? Pick one there, and I'll pick one here. Well, now the rise is actually negative, and our run is over here. And if we connect the two and complete the triangle, we can see that this slope right here, is different than this slope right here. So we ask, what is the slope of this line? Well, if you pick any 2 points on this line, you're going to get different slopes, right? if I pick a point here and a point here, I draw across, that's just a flat line. If I pick a point here and a point here, that's a really tall slope. If I pick one here and here, that's a really low slope. So you can get any combination of points and get any slope. So that this question doesn't really make any sense. If I ask you what the slope of this line is, any 2 points we pick is going to give us a different slope, and we can get infinitely many slopes. So we have to redefine our thought of slope from being 2 points to being 1 point. So we asked what the slope of this curved line was, and we saw that it was different for different pairs of points. So we have to redefine what our question is, because this question doesn't make any sense anymore. So now our question is, what is the slope of a point on this line? So we're going to zoom it in from this whole curve to just 1 point. So I drew a point. Now think about this for a little bit. It may not make any sense because our definition of slope was that we had 2 points. If this is a point and this is a point, our slope was subtracting the y's and the x's. This case, we only have one single point. So we can't find the slope. We can't find the slope of a point because we're not able to find the increase in the y and the increase in the x. 1 point doesn't have any rise or any run. 2 points do, but 1 point doesn't. So what we have to do is actually find a line, because we can draw slopes, or we can find slopes of straight lines. So if we draw a line that goes through this point here, we're trying to find the slope at this point. If we draw a line through that point that has the same slope as the point does, so we draw a line and the slope of the line is the same as the slope of the point, then we might be able to find the slope of the actual point. Now this line actually has a name, and it's called a tangent line. So a tangent line touches a curve at 1 point, and this is the point that we're going to make it touch. It touches at 1 point, and it has the same slope as the point that it goes through. So what would that line look like? Well, if we dotted out this whole graph, we could kind of see that if you drew a line like that, or like that, or like that, that's not really going to represent the slope at that point, because like the slope here, if we were to draw between 2 points, would be down like that, and then over here it would look like that, over here, like this over here, and then over here it would look something, if we pick like a point there and a point there, look something like that. So if we drew a line like that or like that, that wouldn't really make any sense. So our tangent line is going to look like the same slope that the point has on the graph. So it touches only once at that specific point. So if we are able to find the slope of this tangent line, so these over here, these are secant lines, they go through 2 points. This tangent line touches at 1 point. If we find the slope of this tangent line that touches at the point we want to find the slope of, if we find the slope of this line, we should be able to find the slope of this point.